So this is question one. In question one, the 1000 stands for 1000 milliseconds or 1 second, and it pauses the program for that time. This is question two. So the difference is digital write allows you to set the pins either high or low, so like 5 or 0 volts, but nothing in between. On the other hand, analog write lets you set a specified duty cycle between 0 and 255. For example, it can let you control the brightness of a LED by setting the pin between 0 and 255, but digital write, you can only turn the LED off or on. These are 5. So this is question 1 from the in-lab part, blink. It turns on, then it stays on for a second, then it turns off, then it stays off for a second, then it repeats that cycle. This is the code right here, the sample code. So this is question 2 of the in-lab. I declared the variable right there, and then I set it to 500 this time. In the first question, it was 1000. And then you can see it's blinking faster than before. It turns on and off every half a second instead of 1 second, as in the first question. So I changed the code from 1000 going all the way down to 10, and I found at 10 I can't really see if the LED is blinking anymore. This is what it looks like. It's reasonable because our brains only need 13 milliseconds to process what we see. This is question 3, fade. So in this one, it starts at pin 9 and it goes into the resistor into the LED, then the LED is connected to ground. And this is the code for that. So what is happening is it starts at 0 brightness and it's increasing by the fade amount of 5 until it goes up all the way to 255. Then when it gets to 255, it will fade back down to 0 again and it will go back up, so repeating the loop. If you change the brightness variable to a different one, what happens is it starts at a higher brightness variable. So for example, instead of starting at 0, you start at, say, 150. It's going to be more bright. And this is question in lab 4, and this is my code for that. The main thing here is the fade amount, because that sets the frequency to slow, medium, or fast. It's on 2 right now, and you can see that the LED is going slow. So if I change that fade amount from a 2 to a 4, you can see now it's on medium speed. It's faster than before. Finally, for the fast frequency, if I change it from a 4 to a 6, you can see that now it's going faster than before. So this is still question 4. In this one, though, I changed from manual to automatic, so the frequency in this code goes automatically from slow, medium to fast, instead of you changing yourself before running the code. So to do that, I basically use switch case, and I use a var. So if it's case 0, it's fade amount times 1. If it's case 1, times 2. In case 2, it's times 3. And if it goes more than times 3, case 3 will bring it back down to 1. And this is the rest of the code. So you see it's going to start at slow right now. Now it's going to go to medium. Now it's going to be fast. Now it's going back down to slow again, so I'll just repeat that. So lastly, in question 4, I think for the fading exercise, I think the PWM has mostly advantages. There aren't no disadvantages. For example, the code is much cleaner, requires less work, and it's a lot easier to set the fade frequency. And doing it manually seems counterproductive to become better at efficient coding. This is question 5. So what I did here was fading multiple LEDs. The first one is going at a slow frequency. The second one's going at medium frequency. The third one is going at fast frequency. And the fourth one just blinks twice and it's going to restart the cycle again. So this is my code for question 5. So I declared all my variables right here. LED brightness, fade amount, and the period, and the increment for the switch case, and delay time. And then I made all the pin modes outputs, the 4 pins. And then these are I use switch case. So when it begins, the brightness is going to be 0, so it will start with case 0, which means it'll go onto the first pin where the fade amount is 1, so a slow frequency. Then it will come down and it will turn on the LED for a lowest amount of time and highest amount of time. And then when it gets to its maximum brightness, the fade amount is going to switch to negative, and then at the maximum brightness, it's going to blink 2 times. Then with the negative fade amount, it's going to come back down to minimum brightness and blink again 2 times. And then after that, using switch case, since the brightness is 0, it's going to move on to case 1. And it's going to repeat that cycle. And when the brightness gets to 0 on that LED, it's going to move down to case 2 and go to the next LED. And when that comes down to 0, it's going to go on case 3, and then it's going to repeat.